Welcome, STEMgineers, to STEM to Stern, the podcast where curiosity meets critical thinking. Join Chauntée and Jake as they discuss STEM topics that spark debate and exploration.
Hey everyone, I'm Chauntée.
And I'm Jake.
And welcome to STEM to Stern. Today's topic is quantum computers and parallel universes?
So what do those two things have to do with each other? It kind of sounds like a science fiction movie.
It definitely does. It feels like you're about to make up a whole story, which I'm into. So let's go.
Well, I'm not gonna make it up. I'm actually gonna deliver you the science behind it. So yeah. So you guys should actually check out a blog that I wrote recently on our STEM Education Works website about quantum computers. Specifically, I wrote about Microsoft coming out with their chip, the Majorana 1. And what's special about that to me is because I actually used to work over at Purdue for one of the labs that worked for the Microsoft quantum computing project.
So you were kind of helping behind the scenes of what came out.
Yeah, I was a lab manager there. So
lab rat.
Yeah, exactly. And the thing that we were trying to accomplish there is to build like little quantum transistors. And what is a quantum transistor, you ask? Thank you, Chauntée.
Yes, absolutely. That was my next question.
Terrific question. So quantum computers basically use the principles of quantum mechanics in order to compute things. And so instead of using like a normal traditional transistor that's either off or on, a quantum transistor can be off or on or a superposition of anywhere in between.
So it's like a state without being a full state almost?
Yeah,
a state of matter, but without being a state.
That's actually true because that's what we call an uncollapsed wave function in quantum mechanics. So like in quantum mechanics, you may have heard that like particle can be in two places at the same time before it's measured. So we're kind of taking advantage when we're building quantum computers. These organizations like Google or Microsoft or IBM, they're basically utilizing the principles of quantum mechanics to be able to build stronger and stronger computers that can calculate things so much faster than a traditional computer.
So for like the real world application, it could be something that helps with like solving medical mysteries, curing things.
Yeah, there's actually a lot of like within the realm of like running simulations for like certain drugs to cure certain diseases. It'll be really helpful for things like that in the future, as well as lots of other things.
That's amazing.
And you mentioned something earlier, just a second ago, about parallel universes.
Yeah, what are we about to get into some Marvel conversation?
I don't know. Can you explain to me how the parallel universes work?
Probably not.
Okay, all right. I'm just kidding because this is something I did some research for, but
I'm also not familiar with any of this debate, so this is why I'm here. I'm learning just like you guys.
So the reason why quantum computers have to do with parallel universes is because within quantum mechanics, there's a certain interpretation that, like, when you're taking a measurement of a quantum system, it's like totally probability based. Like you have a 20% chance of getting this result, a 30% chance of getting this result, so on and so forth. And so before you actually take your measurement, the wave function is uncollapsed. It hasn't chosen a specific state yet. And so one interpretation, the many worlds interpretation of quantum mechanics, states that when we make a measurement here in our universe, the alternative result of that experiment happens somewhere else in another parallel universe.
What?
Which is it's a very theoretical thing.
This is like the Flash come to life.
Pretty much. And yeah, it's pretty crazy, but at the end of the day, if this many worlds parallel universe interpretation of quantum mechanics is correct, it means that when we're using a quantum computer, we're kind of interacting with the parallel universe.
Oh my goodness. Okay, so yeah, that makes sense because you have that it's trying to it goes ahead and then comes back concept almost. Is that what you're saying? Like it's reading what is going to happen but goes back and then finds the correct path?
I mean, kind of. There are certain experiments where you can do these like weird like quantum eraser experiments that I was telling you about earlier, and that definitely has to do with quantum mechanics as well, because quantum mechanics is just weird. Like could we achieve like time travel or communication with another parallel universe? It's kind of up in the air, very hand wavy at this point. These are very theoretical ideas, but
All we're
maybe.
saying is it really is about mathematics at this moment.
Very
so
true.
the
Very true.
mathematical time machine, hypothetically. But what do you think about that? I mean, I feel like that's an interesting conversation, and also it's still obviously a big debate, and it's still a lot of research going on as far as what that looks like. So yeah, what would you feel like would be the best part about this idea of being in parallel universes? Would it look like what we think it might look like? Or what does it look like to you? What are you hoping for?
Would you be cool with meeting a version of yourself like with a mustache, kind of like from the cartoons? That'd be pretty
Yes.
cool. Tell us what you think about that in the comments.
Yes, and until next time, see you later.
Thanks for tuning in to STEM to Stern. We hope today's episode got you thinking. If you enjoyed the discussion, subscribe and share it with others. And be sure to check out our show notes for free resources and links that go along with today's episode. Until next time, keep questioning and keep exploring, STEM engineers.